Today we're going to start off by looking at exponent laws. So first I'm going to ask that before you view the videos that you've gone and looked at the notes that I've provided in the Google Classroom for the exponential relations unit, where I go over the actual laws in detail, and here we're just doing some more examples. So our first exponent law example we're going to look at is multiplying, and so notice that we have our like bases. Right, we have the 7 and the 7, and when we're multiplying, when we have like bases, we add the exponents. So we can see we have an exponent of 2 here, and it looks like we don't have any exponent on the first 7, but in reality we have an exponent of 1. Okay, so when you don't see something there, it's an exponent of 1, not an exponent of 0. And with multiplying, we add the exponents. So that means our next line is going to look like 7 to the power of 1 plus 2. We can simplify that to 7 to the power of 3. And then 7 to the power of 3, if we're going to evaluate, this gives us 343. Okay, so this is what we get when we evaluate. That means give me a final answer. Okay, let's go over to dividing. Now, when we divide, again, we need to have the like bases, so the 6 and the 6, and we're going to subtract the exponents. That means we take the first exponent that shows up, which is the 3, and then we subtract the second one from it. So we have 6 to the power of 3 minus 2. That gives us 6 to the power of 1, and 6 to the power of 1 is just 6. So there we've simplified to get a power with a single exponent, and then we have evaluated. Let's go to the third one, power of a power. So notice we have 3 to the power of 2, and then all of that is then to the power of 4. So the rule here is that we multiply the exponents together. So we have 3 to the power of 2 times 4. That gives us 3 to the power of 8. And then if we evaluate that, we get 6,561. Next, we have our 0 exponent. So here we have 135 to the power of 0. It kind of looks like 135 degrees, but what we have going on there is 135 to the power of 0. Now this is going to give us 1 because any number to the power of 0 is equal to 1. And lastly, we're going to take a look at negative exponents. So here we have 3 to the power of negative 2. What we're going to do is we are going to flip it. So what I mean by that is we are going to imagine that we have 3 to the power of negative 2 over 1. And now we are going to switch the numerator and the denominator. So we end up with the 1 on top. And now on the bottom, instead of the 2 being a negative, we have 3 to the power of positive 2. So now we've expressed this as a power with a single positive exponent. So let's write that down. So we have a power with a single positive exponent. And now we can evaluate because 3 to the power of 2 gives us 9. So our answer here is 1 over 9. Next up, we're going to do a much more difficult question where we kind of combine everything together. So we are going to simplify to a single exponent power, and we want it to be a positive. So I'm going to just add that in there. So we want our single exponent to be positive, and then we're going to evaluate it at the end. So we want to make sure that we are working from left to right and also going with BEDMAS here. So we have 2 to the power of 4 divided by 2 times 2 to the power of 2, and all of that is divided by 2 to the power of 3, all to the power of 2. So the first thing I'm going to add here is a little 1. So we remember that that 2 actually has an exponent of 1. And we're going to do our division. So we're going to work one step at a time. So we have 2 to the power of 4 and then minus 1. And then all that's going to be times 2 to the power of 2. Now on the bottom in the denominator position, because we have this power of power all by itself, we can actually work with that right now. So this is 2 to the power of 3 times 2. Okay, so our next line, we're going to end up with 2 to the power of 3, because 4 minus 1 is 3, times 2 to the power of 2. And all of that is going to be over 2 to the power of 6. Next, we're going to do the multiplication on top, which means that we are adding the 3 and the 2 together. So that's going to give us 5. So we end up with 2 to the power of 5 all over 2 to the power of 6. And so this really is division, right? 2 to the power of 5 divided by 2 to the power of 6. So we're doing 2 to the power of 5 minus 6, and that gives us 2 to the power of negative 1. Well, we want our final answer to have, or not even our final answer, but we want to express it as a single exponent power, and we want that exponent to be positive. Right now it's not positive. So we need to do what we did in, I believe it was example 5, is we need to do a little flip here between the numerator and the denominator. So this is going to give us 1 over 2 to the power of 1, and then we are asked to evaluate. So that means actually apply that exponent, and 2 to the power of 1 is just the same as 2. So 1 over 2 is our final answer.